All right, we're going to go over this lab, the introduction to measurement. I put some key points on a PowerPoint here to discuss what we should have been doing, and maybe we can understand if we missed something, we can understand why that we missed that particular problem. So let's look at this chart, and I don't know whether I made up these numbers or I got these from one of your labs. But the very first thing we need to do, we're talking about deviation, okay? So we want to know how far that our measured volume is from the average volume. So in order to get the average volume, I'm going to add 16.9, 16.0, and 16.6. And when I do that, I get a value of 49.5. And what I'm going to do is I'm going to divide that by 3 to get my average. So when I take that and I divide that by 3, I get an average of 16.5. Now, when I have my average there of 16.5, I need to calculate my deviation. And up on the board here, I put deviation is the absolute value of the measured volume minus the average volume. So we're determining how far off they are from each other. Okay? As I do this, I'm taking, first of all, 16.9 minus 16.5. So that gives me a 0.4, correct? Now, is that right sig fig wise? We're adding and subtracting, so we're looking at the places, right? Because I had people putting stuff like this on there, doing it 3 sig figs. Okay? That's a little bit too precise for our measurement, right? For the tool that we were using. We should only have a significant digit to the 10th place. Can we agree on that? Okay. Now, 16.5. Okay. I've got 16.0 minus 16.5. So that's going to give me a negative 0.5, but I have the absolute value, right? I have the absolute value. Some people left these as negatives. Okay. Absolute value that. So my deviation is 0.5. And my last one, my measured value is 16.6 minus 16.5 for my average. Gives me 0.1, 0.1. Now what I'm going to do is I am going to get the average of that. So I am going to take 0.4, add 0.5, and 0.1. So that's going to give me 1.0. Is that okay, sig fig wise? Yeah, because I added those together, right? Actually, I got to divide that to get my average, don't I? So I have 1.0. So I'm going to take 1.0 and I'm dividing that by 3. Now remember, that's what we call an exact number, isn't it? Okay? So do we ever use an exact number on our sig figs? We do not. So how many sig figs am I going to have here when I'm dividing that out? I'm dividing, so what do? Okay, we're not using the exact number. How many sig figs there? 2. Okay, so we're going to use 2. So I'm going to take that 1.0 and I'm going to divide that by 3. And that's going to give me a 0.33. Okay, so I'm going to switch ahead. My average is 16.5, 0.33. So I'm going to put this in here, 16.5 plus or minus 0.33. So basically, when we're doing the deviation, okay, when we're doing the deviation, we are seeing how close these values are to each other. What is that? What is that? How close each of your measurements is to each other, Austin? That is the precision. Okay? That is the precision. We're seeing how precise we are. So now I'm going to clean up my data table here a little bit. We're going to go on and we're going to do for the 100 milliliter graduated cylinder, 17.4 plus 16.2 plus 16.7. Okay, that gives me a value of 50.3. When I divide that by 3, it gives me a value with sig figs of 16.8. So now once again I do the deviation, okay? The measured volume of 17.4 and I subtract 16.8. So that gives me 0.6. Is that correct sig fig wise? Yeah. Okay, once again, I am subtracting. So I'm looking at my decimal places. It should be in the 10th. Okay. Now I'm going to take 16.2 and I'm going to minus the average of 16.8. So that's going to give me also a 0.6. It gave me actually a negative 0.6, but I took absolute value, right? Then I'm going to take 16.7 minus 16.8, absolute value that's going to give me a 0.1. So I'm going to add up 0.6, 0.6, 0.1 to give me a 1.3, and I'm going to divide that by 3 to get my average. That's an exact value. So my deviation is going to be 0.43. So 16.8, 0.43. Whoops, wrong way. 16.8, 0.43. So if I'm looking at just my data here, what I just calculated, which instrument did I have the better precision? What do you think, Jillian? Yeah, you didn't sound real confident on that. You're correct. This one was more precise. Why? Why was it more precise? Jaden? The number on the right side was lower, and what do we call that number? The deviation. The deviation was lower for the 25 than the 100 milliliter, so that one was more precise. So now let's think about this. Accuracy and precision, correct? We've been dealing with this. What do we use to determine the accuracy of our experiment? Madison, what do you think? Think about what you just did on an entrance slip, okay? What do we use to determine our accuracy of an experiment? Anything else? Can anybody help her? Okay. Olivia, what do you think? The percent error, okay? We use the percent error to give us the accuracy. So now, what can we use to give us the precision? The deviation. And how do we calculate deviation? The average, the measured volume versus the average absolute valued. Okay? So now we have a calculation for accuracy, we have a calculation for precision, right? All right. Now my next slide says, does percent error measure the accuracy or the precision? I guess I should have done this slide before we just talked about that, because this is easy now, right? What does the percent error measure? Accuracy, okay? Percent error measures how close the measured value is relative to the accepted value. So that is the definition of accuracy. Now, the final thing that I want to talk about here is the average thickness. I measured out 6 nickels, and those six nickels had a length of 11.3 millimeters. Sorry, 11.3 millimeters. When I averaged that out, it came to be 1.88 millimeters per nickel. Well, when I measured out the thickness of 1 nickel, I measured it at 1.8 millimeters. So which method, averaged or measured, do you think gives a better estimate of the true thickness? Okay, I measured this one. I used the average on that one. Which do you think gives up the better estimate? Well, the average thickness is probably the better estimate for a nickel. Why? Well, let's look at this, okay? When I did this one right here, the 1.8, I had to estimate to the tenths right there, didn't I? Okay? Right here, and actually I think this is even wrong, because I used, this should be 1.9 here, because I got a bad sig fig there, don't I? Okay? I took 11.3. Actually, I don't. That's 3 sig figs. It should be good. Okay, let me look on my sig fig calculator. 11.3 divided by the exact value of 6 gives me 1.88. Yeah, that's right. So that's sig figs, right? So as I'm looking at this, okay, I took this to the 100ths place, didn't I? This one was only to the 10ths place. So which is a more precise measurement? Okay, the further I take out. The further I take out. So the average is going to have more precision than what the actual measured was, and that was just because of my significant digits, okay? Any questions over this lab? If you have any questions of why you missed something, make sure you come up and ask me. I'll explain it to you.